Today we are going to study about the nomenclature of alkenes and alkynes. Like you know that alkanes also have their common and their trivial names, but in the same way alkenes also have common and or trivial names. And for naming an alkene according to their common or trivial names, the name ane, the ending name for alkanes, ane, is replaced by ylene, Y-L-E-N-E. But you know that the use of common names is quite limited. Why? And it's not workable with organic compounds. Why? The reason is that organic compounds are mostly, they have complex structures, they have complicated structures. So with by using the common names, it is difficult to get the information about their structure and the bonding. So but still this can be used for smaller organic compounds, like if I make a carbon chain of 2 carbons, it would be CH2 double bond CH2. So how am I going to name it? I will replace the ane from alkane with Y-L-E-N-E. So the name would become ethylene. Okay. Similarly, if I draw a chain of 3 carbons like CH3, CH double bond CH2, it's a chain of 3 carbons, so the name would become propylene. And if I make an isomer of butane, for that I will make a chain of 3 carbons. The fourth one would be present as a group or substituent. Now I can put double bond anywhere like this. Now I'm just writing the number of hydrogens to satisfy the valency of carbon. Now as it is derived from isobutane, so here the name would become isobutylene. Now let's move to the IUPA system of naming the alkenes. The first is that we have to select the longest continuous chain. So if I number it like this: 1, 2, 3, 4, 5, 6, 7. Here I have a chain of 7 carbons, and if I go like that: 4, 5 and 6. See, so it's a small chain. But now let's see what's written over here, that we have to select the longest chain of carbon that contains carbon-carbon double bond in it. Now you can see that the chain, if I check the chain of 7 carbons, there is no double bond in it. So I will not select that as my longest possible chain. Instead of that, I will go for the 6 carbon chain in which the double bond is included. The next rule is number the chain so as to include both carbon atoms of the double bond. Numbering begins from the end nearer to the double bond. So over here, as you have seen, that the numbering should be done from the end that is nearer to the double bond. So I will start numbering from my right hand side: 1, 2, 3, 4, 5 and 6. So always number from the end which is closer to the double bond. Next is that designate the location of the double bond by using the number of first carbon atom of the double bond as a prefix. Now over here you can see, if I number it like this, my double bond is present between carbon number 1 and 2. So out of 1 and 2, I will select the lowest number and the name would become 1,1-butene. And over here I'll again number from the left hand side, and the double bond is again present between 1 and 2, so I will select 1 and its name would become 1-pentene because it's a chain with 5 carbons. Next is that indicate the location of the substituent groups by the number of carbon atoms to which they are attached. Over here you can see the chain, and there is a group or a substituent attached to the chain. I'll number the chain 1, 2, 3, 4. For naming it, I will first show the location of the substituent, means to which carbon number it's attached to. It is attached to the methyl group, is attached to carbon number 2. So I will write 2, then the name followed by the name of my substituent. It's a methyl group, 2 methyl, and then write the name of the uh, chain, which is 2 butene. In the second case, it is 1, 2, 3, 4, 5, 6. Now you can see my chain is of 6 carbons, and at carbon number 2 I have a substituent, then I have 2 more substituents attached to carbon number 5. So how am I going to show their location? I'll write 2, 5, 5. See, all the three substituents are the same, which are methyl group. So I will write trimethyl, and then 2 hexene. Okay. If the parent chain contains more than one double bond, so then they are called alkyne for 2, alkyne for 3, and so on. Here you can see a chain with 2 double bonds, so I'll just number it, and I'll see the first double bond is present between carbon number 1 and 2, the second double bond is present between carbon number 3 and 4. So I have to select the lowest number, which is, out of these, it's 1 and 3. So 1, 3, butadiene. That would be the name of the chain. The next is that now we have to start with naming alkynes. In the case of alkynes, again the ane is replaced by ine. In this case, the alkane from the word alkane is replaced by y and e. So the name would become, we will call it ethine, and this one would become propine. Okay, if you number it, the triple bond is present between carbon number 1 and 2. Again, I will select the lowest number, which is 1 propine. So the position, again they are telling that the position of the triple bond is shown by numbering the alkynes. So the minimum number is assigned to the bond. Like again, I'll number it 1, 2, 3, 4. I will select the lowest number. My triple bond is present between 1 and 2, so I'll call it 1 butane. And over here a group is also present, which I will name first. So it would be 1, 2, 3, 4, 5, 6. The group is attached with carbon number 5, so its name would be 5 methyl 2 hexane. Alright, and if there is a chain with 2 triple bonds in it, so what would I do? Again, I would select the smallest number, and the name would become 1, 5 hexa, because it's a chain of 6 carbons, so it will become 1, 5 hexa diene. Now the problem comes when both the double and triple bonds are present in the same chain. So here you can see that the chain is starting with a triple bond, and in the next example the chain is starting with a double bond. So how are we going to number? We will number whether it's from the end which is closer to the closer to unsaturation. It can be a double bond or triple bond. So we'll not give preference to anyone, but we'll start numbering from the end which is closer to the double or triple bond. See, like this is how we are going to number the chain. And how are we going to write the names? We'll write the name of the, always we write the name of the double bond first and then followed by the triple bond. So in this case it will be written like 3 pentene 1 ine, and over here it will be 1 pentene 1 pentene and 3 ine. But if both the double and the triple bond they are present at the same positions, then we always give preference to the double bond. That means we'll start numbering from the end that's starting or that's closer or starting from the double bond. So here the name would become, as we have a group as well which is attached to carbon number 3, so we'll write that name as well. We'll mention the substituent first, which is 3-methyl, and then it's 1 pentene 4 ine. I hope the nomenclature of alkene and alkynes is clear to you, and now it's the practice time. So the formula is, the names are given and we have to draw the structure formulas. If you see, it's written 3 n-propyl, that means this is the group, and the parent chain is 1,4-pentadiene. Chain is of 5 carbons, di means 2, and ene means it's a chain of 5 carbons, 1 2 3 4 5, and it has 2 double bonds in it. So I have to number it first. See, and now I'll show the position of the double bond. It is between 1 and 2, carbon number 1 and 2, and 4 and 5. And with carbon number 3 we have n-propyl group, that means CH2, CH2 and CH3 group attached to it. We just now have to write the number of hydrogens so as to balance, to just satisfy the valency of hydrogens, carbons, like this. Okay, in the second one it is 4-methyl, which is the substituent 2-pentyne. That means it's a 5 carbon chain, 1 2 3 4 5, and again we'll number it first, 1 2 3 4 and 5. The triple bond is present between carbon number 2 and 3, so over here I'll make the triple bond, and with carbon number 4 there is a methyl group attached to it. In the end I'll just write the number of hydrogens with each carbon, like this. So I hope it's all clear to you. Thank you for watching. Please like, subscribe, comment and share.